What's going on, everybody? It's Mr. Gustin. I'm back in the physics classroom, and today we are going to be doing just an average speed lab in our packets, okay? So if you missed this lab today, I'm going to do the lab for you. I'll talk about some of the challenging analysis questions that we have, and then I'll just leave you to go ahead and finish up the data analysis and calculations and analysis questions that we have for the rest of this lab. The big idea behind this lab is that we're looking at the differences between initial velocity, final velocity, and average velocity. So there's three types of velocities we have: the initial, or our y-intercept on our VT graphs, starting velocity, final velocity at the end of a traveling object's path, and then average speed. Similarities and differences between all those things. So for materials here, I have got a ramp. This ramp right here will serve as my way to accelerate an object down it. I've got a ramp. I need a meter stick. I need a stopwatch, which I'm going to use my phone for. I can just use that on my device, or you can use it at home. So I want you to use your stopwatch at home while this happens. I also need an angle indicator and a photo gate. I've already measured my angle. My angle is 7 degrees in here. I'm going to pull up my stopwatch, so I have that. And I'm going to grab a meter stick so I can figure out how far this car travels down this ramp. Now, the setup is this. The setup is the car moves down the ramp. I've got my Hot Wheels track right here set up. It moves down the ramp, and I'm going to time how long it takes to travel this distance, okay? So let's do that right now. Let's go ahead and take a measurement of how far I'm traveling. I'm going to hold my car in place and get a measurement here. It is going to travel down to the photo gate a distance of, let's call it 80 centimeters. So 0.8 meters is the distance it's going to travel down this ramp. Now that I have distance or displacement, delta x, I'm also going to want to include a time value, because I know that average velocity is simply change in position or displacement over time. Displacement is 0.8 meters. I want to find out the time now to then calculate the average velocity. So we're going to go ahead and do that. We're going to go ahead and time the time it takes the car to go from here down 0.8 meters to the bottom of the ramp. So let's go ahead and do that. Are you ready? 3, 2, 1, go. I have 1.13 seconds. So here's my data. My data is displacement is 0.8 meters, and my time is 1.13 seconds. This is the data that I have. Now, in the second part, I want you to use your photo gate to go ahead and actually measure the speed of the car or the velocity of the car at the bottom of the ramp. This is the final velocity that I am measuring. I can go ahead and use my delta x in time, plug it into my average velocity equation to find average velocity. I want to see how that compares to my final velocity. So again, dropping it down the track, the 0.8 meters, I'm measuring in meters per second. That's why it's 0.8 meters. And if I drop it, let's go. I get a final velocity, measured final velocity of, so this is part one, my final velocity when I measure it is 1.46. You can see it there, 1.46 meters per second. That is my final velocity that I have measured, all right? I can use my other average velocity equation to then calculate average velocity using initial velocity, which is 0. It started from rest, adding it to that 1.46 and dividing it by 2. Maybe those two things add up. Maybe they don't. I don't know. That's your data, okay? That's the entire lab that we did. That's all of the data you need and measurements. However, I think the tricky part about this lab is less gathering the data and more question number 4. So let's go ahead and look at question 4. Question 4 says, it asks, is the final speed at the bottom of the ramp equal to your average speed? And no, it certainly shouldn't be. Average speed is a measurement of displacement over time, whereas final speed is an instantaneous velocity. Those two things are different when an object accelerates. So no, let's calculate the distance the car rolls or let's call this distance the car rolls d. I want you to change that in your packet. Change it to delta x. I want to talk about displacements and velocities. I don't want to talk about speeds. So let's call the distance the car rolls delta x, like we have right there. Let's call the time t, fine, and let's call the final speed, let's call it velocity, v. Now it says derive an equation for v in terms of d, change d to delta x, in terms of delta x and time. Derive an equation is something we haven't done before, so I want to walk you through what that might look like, okay? So I've got two equations for average velocity. The first is average velocity is displacement over time, or delta x over time. The other, or second average velocity equation we can use is final velocity plus initial velocity divided by 2. That's just a simple average of velocities. Those two equations both are average velocity. Now I'm asking you to go ahead and derive an equation for final velocity, which is VF, okay? So since delta x over t and VF plus V naught over 2 are both equal to each other, I want you to set them equal and isolate VF. When you do that through your steps in algebra, you should arrive at my answer down here. You should arrive at VF being equal to 2 times delta x over time. I hope you arrived there for number 4. That's a new equation, a derived expression we have for this scenario, especially since initial velocity was 0 here. Okay, so the rest of this lab can be finished up through analysis questions, analyzing your data, looking back through your notes and that kind of stuff. So I want you to do that. If you have questions, email me. But until then, see ya!